Yeah, so directed numbers is a source of a lot of problems for students. All right, now what we like to do as students is just learn the rules for multiplication and division, which is a minus and a minus is a plus, a plus and a minus is a minus, and we apply that to everything. All right, but the truth is that in directed numbers, we have, two sets of rules. One set of rules for addition and subtraction, and another set of rules for multiplication and division. And we have to know when to apply which. All right, so first let's start with the rules for multiplication and division. That's the most common one. All right, so just going to write here multiplication and division. Right. So, what I'd like to say is that the signs in front of a number is part of a number. So, you'd have heard me, I would have said so in times past. Okay. So, let's say we have 0 here, and here we are -1. Sorry. +1 on the right, and the left is negative. -1, -2, and so on. All right, so the symbol 1 is the same as the symbol 1. The symbol 2 is the same as the symbol 2, but yet these have different values in maths. And what causes that difference in value is the sign that's in front of the number. You see, there's a negative sign in front of 2 here and a negative sign in front of 1. That makes it different from this 1 and this 2. All right, in front of this one here, we have a positive sign, and in front of this 2, we have a positive sign. So basically, when you're doing algebra or anything, you can't just look at the number alone. You must look at the sign in front of the number, because that sign in front of the number is part of the number. Okay, the number don't exist on its own and the sign separates. They go together. All right? So if you're moving numbers around or anything like that, you always have to consider the sign in front of it. When you're adding and subtracting, multiplying and dividing, you always have to consider the sign that's in front of the number, whether it's positive in front of the number or negative in front of the number. Notice the sign is not behind the number, it's in front. Okay? So now, with multiplication and division, I like to say that if the signs in front of the numbers are the same, your answer is positive. If the signs in front of the numbers are different, your answer is negative. We go that rule. Okay? So I'm going to write it out. So if the signs in front are called two numbers, are the same, the result I use answer instead of result. The answer is positive. All right, and this is a symbol we can use for positive. Plus the VE means positive. All right. So, and that's for multiplication and division, right? That's our heading. So let me demonstrate. All right, so we could have example, -2 times -5. Now notice I put our brackets here because we have this multiplication sign and it's clashing with this negative sign here. So we want to put a bracket to separate this sign, this sign from this sign. All right, so that's why we had the brackets there. All right, now basically signs in front of the two numbers are the same, being negative. So our answer will just be positive 10. All right, according to our rule. Now, even if we had now I know everybody know how to multiply and divide, right? So this is not an exercise on how to multiply and how to divide. It's about the signs. Okay, so 2 times 5. All right, again, the sign in front of 2 is positive, and the sign in front of this 5 is positive. All right. So basically, the signs in front of the numbers, they are the same. And that's why your answer is positive. So by saying the rule like that, you sort of summarize things, you know? So it don't matter. 2 negatives, answer is positive. 2 positives, the answer is positive. The signs in front of 2 numbers, they are the same. Answer is positive. All right. It goes for the division as well. All right. Bring a line down here. All right. So if I had same thing, -2 divided by -5. How would I write that? I write that as -2 over -5. All right. And because the 2 of them are the same signs, the answer is positive. So let's write +2 over 5. Okay. So I'm going to move myself to the left. Oh, right, sorry. Okay. So again, that's the example. And if we had same thing, 2 divided by 5, well, that's just +2/5. All right. We could break that down as a decimal if you want to. All right. Demonstrate on the calculator. Pull my calculator up. Right. Let's bring it across here. So how do we write these answers on the calculator? Well, use the calculator to get the answers of this fraction. All right. Let's have to put 2 divided by 5. All right. Let's press change. And I say get a decimal 0.4. All right. So that means I could have written this as positive 0.4. And same thing here. This is positive 0.4. All right. So positive answers, signs are the same. All right. So let's look at the next rule now when the signs are different. Good. Got a space here. Okay, so this would be like rule number 1 for multiplication and division, and then rule number 2. All right, so we have when, move the calculator. Right, so when the signs in front, the 2 numbers are different. All right, the answer is negative. All right, symbols are negative sign with VE for negative. All right, so what I mean different? Well, if one is positive and the other is negative, then the 2 signs are different. Okay, so example, I use the same numbers that we have. Example 1, if I have +2 multiplied by -5, all right, as you can see, 1 is positive, right, because it means in front of the 2 is a positive sign, all right, so the signs are different, 1 positive, 1 negative, different, the answer would be negative, so you get -10. All right, even if I had -2 multiplied by 5, then that means that this is negative, this is positive, so the 2 signs are different, so the answer is negative, so you get -10. All right, example 2. For this one, example 3. Let's look at the division now. So if you have 2 divided by -5, that's simply 2 over -5, which you can write the whole thing as a negative sign in the middle like that, and 2 over 5. Okay, that symbolizes that the entire fraction is negative. Okay, and as we demonstrated on the calculator, that -2 over 5, well, 2 over 5 is 0.4, so you get -0.4 as a decimal. All right, so let me erase that. Right. Let's move myself across. Right. Yeah, so, and same thing. If I change it around to, say, example 3, right? If I put a negative sign in front, negative 2 divided by positive 5, signs are different. So that's been negative 2 over 5, all right? Which is just simply mean the entire fraction is negative, so negative in the middle, all right? Negative 2/5, which is negative 0.4. Okay, so, and I think this is the most popular rule, all right? Negative and negative is a plus and a negative is a negative, all right? But you see how I summarize it. Either the sign is the same or the sign is different. Once they're the same, the answer is positive. Once they're different, the answer is negative, okay? So as that's simple, okay? There's nothing more to it than that. Everybody should know how to divide numbers, to how to multiply numbers. What we're interested in is the sign for the answer when we have directed numbers. Okay? So I'll put this page on the Jamboard. All right. And we'll move on to the next page where we look at addition and subtraction. Now, because we run a condensed program, okay, I would you see how I'm doing directed numbers here, using my discretion now or my experience as a teacher now to summarize things. All right, so yeah, we're doing directed numbers. Directed numbers is applicable in algebra. All right, but there are some simple applications in vectors and matrices where we could use, instead of just telling, hey, work out with negative 1 plus 3. Instead of doing that, I could put things probably in a matrix or vectors, okay? Or some algebraic terms, and test your knowledge of directed numbers while at the same time covering the simple aspects of simplifying algebraic terms and also adding and subtracting vectors and also matrices. All right, so that's like killing two birds with one stone. Okay, so let's go on to the addition and subtraction. All right, so now the rules for addition and subtraction. All right, so we established that the sign in front of the number is part of the number. So anything we do in mathematics, we always consider the sign in front of the number. Okay. Now let's see what happened with addition and subtraction. So we're going to have the same situation. Either the signs in front of two numbers going to be the same or they're going to be different. All right. Now, let's write a number. Let's say negative 3. All right. Now, what I consider this, this 3 here, I will call that the magnitude. All right. Now, in mathematics and also science, we have two types of quantities. We have vector quantities and we have something called scalar quantities. All right. Now, I know we're not doing vectors as yet, all right, to discuss the big difference between vector and scalar, but I'm going to mention it because basically a directed number is like a vector. Okay. All right. So the 3 on its own is going to be called the magnitude. Okay. Okay. And the sign, symbol, right, the negative sign, that gives us the direction. Okay, so we have For a directed number, we have direction, magnitude. Let me do the same thing for positive 3. All right. I mean that's simple enough. Positive 3, a plus sign in front of it. I mean the same thing. All right. This is the magnitude. All right. Okay, and the plus sign is the direction. Now, I just don't want to just give you rules just so I want to probably go into a little explanation as to why things happen the way they happen. Okay. Now, when we look at a number line, right? So I'm gonna move myself across. Yeah, so pull up a number line. Okay. The middle here. Follow arrow going this way. Follow arrow going this way. All right. So 1, 2, 3 going like that. Now here we have like -1, -2, -3 going like that. So I gotta check something. So I check something I forgot to check. That's something put into the recording. All right. Forget to check to see how the audio is coming through. Okay. I had it on. All right, nice. Yeah. So essentially in number line, you're seeing we only have 2 directions. All right. The positive direction is going to the right. So this is going to the right. All right. And negative direction is going to the left. So with directed numbers, we only have 2 directions, either right or left. So positive is going to the right and negative is going to the left. But what I'd like to say is this. Yes, think of it as positive going to the right. Negative means to switch the direction to the opposite. So think of negative as opposite. Okay? So I'm going to demonstrate why I'm saying that. So negative is opposite. Positive numbers going to the right. So bring a line down here. I'll write down the rules and summarize, just now, but I just want to demonstrate this. So if I have, let's say, 2 plus 3, all right? Think of it as 2 going this way and 3 going this way. They both going in the same direction to the right. Okay, so now I'll put this as 2 and this as 3. Now, if these were 2 forces, like, somebody pushing in this direction, and you have these 2 forces in the same direction, you'll get a greater force, right? A bit bigger. And that's why I add the 2 and the 3, and I get 5. Okay? Now, if I had, let us say, -2, take away 3, equal. Now, come like these 2 going into the left now, so we have 2 going this way. And just make that better. And you have 3 going this way, right, to the left. So the magnitude is still 2, magnitude is still 3, but they're both going in still the same direction. They're just going to the left, and left is negative. So if they're going in the same direction, you can't get a smaller force. You have to get a bigger force, because if 2 people pushing in the same direction, you're going to get a greater force. All right? If you're pushing in opposite directions, then things will have to subtract, because you get a lesser net force. All right? So same direction, greater force. Opposite direction, you have to subtract and get a smaller force. Okay, so you'll add the 2 and the 3, but it's going into the left, which is negative, so -5. All right, and just out of this simple demonstration here, you realize that if the signs in front of the two numbers are the same, whether it be positive or negative, because in front this is a positive, you would add, right? You must add. So it's not a negative and negative are plus as you seen here. In negative and negative, yes, but you're going to add, but the answer is not positive, the answer is negative. So you're going to add, but whatever sign that is from the two numbers that are the same, the answer taking that same sign. So the two signs are positive, the answer is positive. The two signs are negative, we are going to add, because the signs are the same, but the answer would be negative. All right, I'll write down that, I'll summarize that after. Let's go where things are different. Okay, so let's say I have let me get back black. 2 take away 3. Now this 2 here is positive, so this is positive 2, and positive means going to the right, so we're going 2 this way. All right, so that's 2 this way, but the sign in front of this 3 is negative, and negative means going to the left, so we're going 3 this way, next direction. Now think about it. If two people pushing in the opposite direction, are you expecting to get a greater force or a lesser force? A lesser one, because you're pushing in opposite directions. And that's your signal to subtract. Now, here's where the tricky part comes, because the answer could be positive or it could be negative. It depends on the numbers that you have. But the main thing is, as long as the signs in front of the two numbers are different, you are going to subtract, because the different opposite directions, you have to subtract to get the net force in that sense. You know, two people pushing in the opposite direction, you're going to get a lesser force. Now you have to ask yourself, which direction would this go? The force to the left is the greater force. So obviously, you know, if two people pushing, the person that pushing to the left will basically move everybody to the left. All right, because this person had a greater pushing force then. This person had a less pushing less. So this person gonna lose, right? The 2 gonna lose, the 3 is gonna win. So you're gonna go in a generally left direction. And that means your answer would be negative. All right. Now, if the force to the right was greater, then that means it'll go to the right. And the answer would have been positive. Okay, so the sign for the answer depends on the magnitude of the number. Remember, magnitude, direction. Okay, so the magnitude is 3, the direction is negative, that's the left. 3 has the greater magnitude, therefore the answer will take this sign, this negative sign, because it will go to the left. So the answer here is subtract 2 from 3 and get 1, but the answer will be -1. All right, and I know this has been the tricky part, because yeah, everybody know negative and negative are plus for multiplication and division. But when it comes to addition and subtraction, this is the part that's give problems. All right, because signs are different. The answer could be positive or negative. It depends on the magnitude of the numbers that you have and the sign. The one with the greater magnitude, the sign in front of it, that's what the sign the answer will take in summary form. All right, that's what you look for. All right, let's look at if I switch things around, the 3 is the bigger one now. So if I have -3 plus 2. Now, some students like to say, hey, look at plus sign in the middle here, I'm going to add 3 and 2, but no. Right, remember, it's like forces, right? So I have 3 going to the left this time. So say 3 going this way. All right, that's the 3. And then I'll have 2 going to the right, called positive 2, right? So if 2 people pushing in the opposite direction, you're going to get a lesser force. So that means you have to subtract 3 and 2 and get 1. Now, technically, asking the same question as here, but that's good. All right. So the same thing going to happen. 3 is going to the left. That means the 3 is going to win over the 2 in that sense. The bigger magnitude wins. So the answer will be going to the left. Right? The resultant force will be going to the left, which is negative. So yes, you're going to subtract the 3 and the 2, but we're going to the left. So the answer is -1. All right, -1. All right. If I switch things up now and put the negative in front of the 2 and the positive 3, all right. Now, before going to this one, notice that these 2 questions, they are the same. They look different, but are the same answer, and they are the same. Look at this. The sign in front of the 3 is negative. The sign in front of the 3 is negative. The sign in front of the 2 here is positive. The sign in front of the 2 is positive. So these 2, they are exactly the same. It's just the orientation of the numbers are different in terms of they switch wrong. All right, so different form, but it's still the same thing. Mathematically, they are the same. All right. Now, when we're looking at this question, all right, see, we're going 2 this way, 2 to the left. All right, because negative is left, and the 3 is positive, so that's right. So you're going 3 to the right. All right. So 3 this way, and 2 this way. So again, we're pushing in the opposite direction. So we're going to subtract. We're not going to get a greater force. We're going to get a lesser force. So we have to subtract. If the 2 arrows was in the same direction, you get a greater force. That way you add. Okay. So obviously here, the 3 is the bigger magnitude. It's a greater force. So the 3 is going to win. So you're going to generally move to the right, and going to the right is positive. So that means the answer would be positive. So yes, you're going to subtract because you're going in the opposite direction, but the answer will be going to the right, which is positive. So that's why you're going to get +1 as the answer. All right, so that's my explanation as to, why it is work out like that. So summary-wise, I like to say that, if the signs in front of 2 numbers are the same, all right, you add and keep the sign that's in front of the 2 numbers. The answer will take the sign that's in front of the 2 numbers, right? Whoever sign that is, whether it be positive or negative. All right, but if the signs in front of 2 numbers are different, you're always going to subtract. All right, but the answer will take the sign in front of the number with the bigger magnitude. Okay, so I'm going to write that down now. First, I'm going to put this on a Jamboard, and I'll go to the next page and write down that, summarize the rules. Right. Right. Okay, so going to the next page, we're going to have summarize the rules now. So for addition, and subtraction, 1, if the signs in front, the 2 numbers are the same, okay, add And the answer will have that same sign. Okay? And 2, if the signs in front, the two numbers, are different. Okay? You're going to subtract. And the answer takes the sign of the number with the greater magnitude. Okay, so those are the rules. Okay, probably do some examples at the side here. All right, let's just give you 2 seconds to take in that before we do some examples. All right. All right, so let's start with the first rule. All right. That's the most simplest one. All right, example 1. So again, if I have like -10, take away, let's say 2, signs are the same. So you're gonna add and the answer will be negative. So you get -12. All right. If you have like -3, take away 17, you add 3 and 17, you get 20, but both signs are negative, so the answer has been -20. So it's not that negative and negative are plus, and that's what students get, and put positive 20 for the answer. All right? No, signs are the same, yes, you're going to add, but you must take the signs that's in front of both the numbers, the answer can that same sign. Okay? Now, you know, and then after all that, I drop a question like, hey, where's 3 plus 17? And then people start, take long to answer that, Again, the signs are the same, and everybody know 3 plus 17 is 20, but the signs are the same, positive, positive, so that's positive 20. So you see, it works, all right? Signs are the same, you add, they keep whatever sign that's in front of two numbers, okay? So whether it be negative, answer negative, and if the both of them positive, answer positive. All right, so now let's switch it up now to, the one that's give trouble. Okay. So if I have, say, -6 plus 10, no, you're not going to add 6 and 10 and get 16. The signs are different. So that means you're going to subtract. Which number has the bigger magnitude? 10 is the bigger magnitude. Was the sign in front of it? Positive. So one time I know my answer is positive. All right, and positive is understood. Do I write positive? I just write it there. And now 6 and 10 signs are different. All right, 1 negative, 1 positive. So you're going to subtract. 6 from 10 is 4. So the answer is positive 4. Right? Now positive is understood. You don't have to write this positive sign. I can just write 4. I just put that as to show how I set up the question. Okay, well, taking it one step at a time. All right, so example 5. if I the other way around, 10 take away 6. Well, that's simple. That is 4, right? Everybody know that. Okay. But why it is 4? Well, the sign in front of 10 is positive. For that, the sign in front of 10 is positive. And the sign in front of 6 is negative. The signs are different. So you have to subtract. Which one has the bigger magnitude? 10. Therefore, that's why the answer is positive. Okay. So let's put it as, all right, 6 take away 10. It's looking like a take away sign there. Dot 6, example 6. All right, so 6 take away 10. Now when I look, sign in front of 6 is positive, right? So positive in front of 6. Okay, sign in front of 10 is negative. So I'm now going to subtract. So I ask myself, which one had the bigger magnitude? 10. Was the sign in front of it? Negative. So I know immediately that my answer would have a negative sign. And then because these two signs are different, one negative, one positive, I will subtract and get a negative answer. All right, so 6 from 10 is 4, and that's why I get negative 4. Okay, so it's pretty simple. All right, when you think of it like that, either the signs the same or the signs are different. All right, so I'll show you one where the signs are different, you get a positive answer. I'll show you one where the signs are different and you get a negative answer. Once you know how to add and subtract, yeah, no problems. Now, let's demonstrate how to do this on the calculator, because that's an important thing. Something you can, your brain want to do all that work. Now, for the multiple choice, you need to know how to do it with your rules and stuff. Okay, you have no calculator any multiple choice. All right, but let's see on the calculator. So let's look at the first question. Negative 10 take away 2. Now, you see this negative sign here? That's for the operation negative. You see this down here? Some calculators might have a plus/negative. That is what's convert a number to being a negative number or positive number. So you're not going to use this negative sign for a negative number. Okay? Well, you don't know how to use it. So, like in the first question, negative 10 take away 2. I'll press the 10. I'll press this to make it negative. Okay, going behind. So I'll press it first. So this to make it negative, the 10. But then for the 2, I'm going to press the operation negative. See the difference I'm doing? And then press the 2. And then give my answer, negative 12. So notice I'll do that again. So for a 10, I'm pressing this to make it negative, not the operation negative. So the sign in the middle, all right? This, we're talking about how to use the calculator, right? This one in the middle, you're going to use the operation negative on the calculator. But this one out at the end here, you have to use the other negative, okay? Some calculators may allow you to use the same button, but not all. So it depends on the calculator. So the general rule is you have to use the special negative sign for out here, but inside here, the one in the middle, you're going to use the operation negative, okay? So I'll do it over. So you see, press the special negative for the outside and put it 10, and then the operation negative with the 2. And see again, negative 12. All right, same thing for the other one. Special negative with the 3. All right, because we only negative 3 take away 17. Then the operation negative with the 17. And you see we get negative 20. All right, let me do the one with negative 6 and 10. So since the negative in front of the 6 first, special negative, the 6, then the operation negative, plus. All right, so now I'm going to delete that. So special negative with the 6 and the operation plus with the 10. All right, and I see the answer is positive 4, which we got. Okay. And then the other one, I'll do the one with 6 take away 10. All right, that's 6 operation negative because it's in the middle, right? Take away 10. And I see you get negative 4. All right, so that's how to use the calculator, all right, to work these things out. All right, so just take it down. All right, so one last thing before we look at exploring a little exercise as to how to do this. All right. Let's put this on your Jamboard first, and go to the next page. Okay. Next page. Now, I showed you multiplication and division, and showed you addition and subtraction. Now, look at the situation here. Of course, example. If I have 5 plus negative 3, see that? Now, this is the operation in the middle, the positive, and this negative sign will be in front of the 3 in terms of direction. All right? Now, the long and short of this is when you have the two signs together like this, you just use the rules for multiplication and division. So you think of it as multiplying. Now, usually in maths, brackets mean to multiply. All right, so you come like you're multiplying the positive sign with the negative sign. And we know when we're multiplying a positive, well, once the signs are different and you're multiplying or dividing, the answer is negative. All right, so you're multiplying the positive sign with the negative sign. They are different, so the answer is going to be negative. Look what I'm going to do that negative sign. So you're going to get 5. No, put it up here like this. Actually, I'll put it down here. All right, so it's going to turn to 5 take away 3 equal. All right, so what took place there is these two signs, okay, the positive and negative get converted into one sign. All right, you multiply positive and the negative, and you get a negative sign. All right, now put arrow. All right, so these two signs convert and you get this one sign. So now that's 5 take away 3 and the answer is 2. Okay, let me switch that around. Let's show you. All right, example 2. If I have 5, but I have take away and instead positive 3. Like that. Now, remember, I'm using the brackets to separate these two signs. And this brackets would suggest that this sign has been multiplied by this one. Okay, that's maths. Brackets, whatever outside the brackets is being multiplied by the stuff, whatever inside the brackets. That's a general rule in mathematics, right? Whatever outside the brackets has to be multiplied by whatever is inside the brackets. So you multiply the negative sign with a positive sign. Again, the signs are different. As long as the signs are different and you're multiplying, the answer is negative. So what you're going to get is 5 take away 3. All right? So again, these two signs convert and give you this one sign. All right? So 5 take away 3, again, the answer is 2. All right? Now, I look at when the signs are different. All right? Let's look at one of the signs are the same. All right, so if I have 5 take away, then negative 3 like this. Now again, signs are the same. So when you're multiplying and the signs are the same, the answer is positive. So what's outside the bracket has to be multiplied by inside. So negative times a negative is a positive. So you're going to get 5 plus 3. All right, so I'm highlight that. So these two signs combine to give you this one sign. Okay. So, well, 5 plus 3, that's 8. All right, so the answer is 8. All right, and I'll do one more, which is just obvious, but I mean, they could ask us a question and try and confuse you, but I see no reason to write a question 5 plus positive 3. All right, but nevertheless, all right, signs are the same. You multiply positive by positive, the signs are the same, so the answer is positive. So these two positive signs will give you a positive sign. All right, so you're going to get 5 plus 3, which is 8. All right, that's how it's to be shading. All right, so these two signs combine and give you this one sign. All right, which is a positive sign. All right, so once you master these techniques, all right, that's directed numbers in a nutshell. All right. All right, you always have to ask yourself, am I first? Am I multiplying or dividing? I have one particular set of rules for multiplication and division. You see, I recognize, okay, brackets. So whatever outside the brackets needs to be multiplied by whatever inside the brackets. So I switch and use my rules for multiplication with these two signs to give me this one sign. But then out here, you know, it's rules for addition and subtraction. All right, so I know how to switch. All right, so you always ask yourself, am I adding or subtracting, or I'm multiplying or dividing? All right, if I'm multiplying or dividing, I know once the signs are the same for the numbers, answer is positive. Once the signs are different, answer is negative. Straightforward. All right, if I'm adding and subtracting, the signs are the same in front of the numbers, I know I'm going to add, but I'm going to keep that sign for the answer. All right, and if the signs are different, I'm always going to subtract, but the answer depends on which number has the bigger magnitude. All right, so the answer will take the sign in front of the number, the bigger magnitude. All right, so that's all you have to ask yourself, and things will work out. You'll get through the questions. It wouldn't be confusing. And if all else fail, you know you have your calculator. So now bring the calculator up and work these questions to show how you'll input this on the calculator. Okay? All right, so I'm a calculator up. Let's move that across so it won't block the questions. This. All right, let's do the first one. All right, clear this off. So we have 5 plus negative 3. That's how we put this in. So I'll press the 5. I'll press the plus because that'll be the sign in the middle. So using the operation plus. But for that negative sign in front of the 3, I have to use a special negative, not this negative, the special negative, this one. Negative 3. Press equal, and you see I get positive 2. Now, if you wanted, I could have put the brackets, but the calculator understands. Once you use the right knobs, you know, it will work out without the brackets. But let's say we wanted the brackets, no problem. 5 plus, open the bracket here, press the special negative, the 3, and close the brackets like that. No problem. 2. Okay? Switch it around to the other one. 5 take away positive 3. So 5. Now, that take away is the one in the middle. So I'm not going to press this one. I'm going to press this one, take away, right? Because the take away is in the middle. To look at example 2, 5 take away positive 3. And if you want to put it positive like this, no problem. Syntax error, so I'll put the brackets. All right. Different calculators are different. That's why it's important that you learn to use your calculator. Okay. So 5. All right. Take away, open brackets, positive 3. Close brackets to see what this will do. All right, so this is not accepting that as positive. All right, this calculator not. Now, what you'll have is that a lot of calculators have this special negative. It's like negative slash positive. So you're able to switch between. All right, so this calculator making you understand that, yeah, well, positive is understood for this calculator, okay? So 5 take away, and if you want to put positive 3, if you press 3 by itself, that means positive 3. Okay, so if you want to put open brackets 3 like that, that's positive 3. All right, and you get your answer. So that's how this calculator operating. Okay, where a positive number is understood. Once you press a number by itself like this, 5 or 9, whatever, it's understood to be positive. All right, that's how this one operating. I say other calculators have a plus/negative, so you can switch between plus and negative with the special knob here. All right, this one does have negative, meaning any number you press is understood to be positive. All right, and it's important you learn how to use a calculator. All right, so the other one, example 3, 5 take away negative 3. So we have 5, the takeaway would be the operation takeaway. Then when we open the brackets, it's pressing a negative, special negative for the 3, like that. Close brackets. And equal, you see a positive 8. All right. And the other way around, well, 5 plus 3, again, 5 plus, and once you press 3, is understood that 3 is positive 8. All right. So let me take a calculator now. So, with that in mind, I say we're killing 2 birds with 1 stone, meaning we're going to apply, I'm not going to ask you what's 5 plus negative 3 and get an exercise like that. All right, that's just too simple. All right, so we're going to look at vectors and matrices. Let's talk about what's a matrix. All right, and we're going to do addition, subtraction, and matrices. I'm going to apply directed numbers to these things. Okay, so let's look at what's a matrix. Probably better if I type that out, as that will be like a topic. All right, so matrices. All right, that's a big word. And I'll tell you movie The Matrix. All right, it was a mathematical concept, and it's a very simple thing. All right, so I'll put a matrix is an A, right? Is a rectangular array of numbers. All right, now let me give an example where it's not a matrix. All right, so this what I'm going to put here is where it's not a matrix. If I write 3, 2, 5, that's not a matrix, because this is in no way representing any rectangle. All right, this is sort of like a triangle, right, in terms of shape. All right, but a matrix is a rectangular array. So if I was to add a next number like this, like, I don't know, 11, now it's like a square. So this is a square matrix. All right, see, 2 here, 2 here, 2 here, 2 here, square matrix. But square is a sort of rectangle, right? All sides equal. So this is a square matrix, but it's a rectangular array of numbers. Okay, and yeah, I can extend it like this: -8, 15. All right, it's no longer square now, it's more rectangle, right? But as you can see, rectangular. But I can't have something like this. This is not rectangular. Okay, so a matrix must be rectangular. Okay, rectangular array of numbers. Okay, now, so I'm just going to put an example. -3, 2, 5. All right. Example 2, 8, 11, -13, 4. See it within the brackets like that. All right. Now that's rectangular, right? You can see shape is a rectangle like this. Shape is a rectangle like that. All right. So that's rectangular. Those are matrices. All right. Now, with a matrix, we have something called rows and columns. All right, remember, killing 2 birds with 1 stone. Matrices simple. Addition and subtraction and matrices very, very simple. No big hard thing to learn here. All right, so once we establish that, we can practice our directed numbers with the matrices. Okay, and a vector is just a column matrix. So that's what I'm going to go into here. Which column and which rows? A vector is just a column matrix. Okay, so that's what start with matrices first. So this what I have here is what we call a column matrix. So if you think about a building, right? Those posts on the building, as you know, is say the let's call them columns, right? Something as a main column that, you know, the structure the building dependent on, you know, those vertical posts on some buildings, you know, that help and hold up the structure. That's a column, all right? So some people the nice kind of column, you see, it's say columns that is by to you know, to put in front of like they call a porch or something, will be a vertical something. So column is vertical. That's I was trying to relate, you know, to something in real life. All right. Now let's say maths, these words unrelated. So column means vertical. All right. So the vertical is called a column matrix because that's all vertical. Okay. And this other one here, since it's horizontal, it's called a row matrix. All right, so column is vertical, row is horizontal. Okay. So let's go to the next example here. 8, -2, 3, 4, 10, -5. Like this. All right, let's move myself across. All right. So in this matrix, yes, it's rectangular. All right, it's a matrix, but I just want to count how much rows and columns we have. All right, so I use blue for columns. So I have 1. You know what? Let me shade that instead and use blue to shade. All right. So 1, 2. Oh, the colors go clash. Yeah. All right. Because I will do rows after and the colors go clash. All right. So 1, 2, 3. So I have 3 columns. Okay. So I have. So this matrix has. I'll put that in black. This matrix has, put in blue, 3 columns. All right. And rows going across. So rows is horizontal. So 1, 2, 2 rows. Okay. So and 2 rows. Okay. Now let's now put a note here. Some little definitions, right? 1, 2. Difficult to understand so far. Columns come down, rows go across. All right. So the order of a matrix is given by stating, okay, let's move myself. All right, given by stating, put some blue, green, rows, right, plural rows times columns. Okay. So, for example, since this matrix here is 2 rows and 3 columns, this matrix, all right, I'll put arrow in red, yeah. This is a, put green, at 2 by 3 matrix. Okay, so why am I doing all this? Because when it comes to addition, everything have rules, right? So when it comes to addition and subtraction of matrices, you can only add and subtract matrices with the same order. All right, so that's why I get into the order. Okay, the order of the matrix, rows by columns. All right, rows are horizontal, columns are vertical. All right, so let's look at a matrix. Horizontal, 2 rows, 3 columns. They call this a 2 by 3 matrix. This is the order of the matrix. 2 by 3 is the order. All right. And now on top here, you might be wondering what's the order of this one. Well, if you look, we have, let's see how much rows we have. Horizontal, we count this as a row. 1, 2, 3. So that's 3 rows. And then coming down is just 1 column. All right. So the order of this matrix, right, this matrix here could be 3 rows. All right, let's guess, space to write it out. All right, so this is 3 rows and 1 column. So this is a 3 by 1 matrix. All right, put a row there. All right, a 3 by 1 matrix. And that's because we have 3 rows and 1 column. All right, come across here, and remember columns are vertical. So here we'll just have 1 row. All right, this is just 1 row, 1 horizontal going across, so 1 row. But vertically, we count these as columns. So 1, 2, 3, 4. So you have 1 row and 4 columns. All right. So this is called a 1 by 4 matrix. That's the order, a 1 by 4. All right. Matrix. Put arrow there. All right, so a 1 by 4 matrix, rows by column. So, I know this is like, what going on here? This is vertical. Yes, you count this as vertical. So we have columns like that. So 4 columns. But across, 1 row. I know it's looking weird too, but come down is just 1. So 1 column, and we count these going across as rows. All right, so 1, 2, 3 rows. 3 by 1 matrix, 1 by 4 matrix. This is a 2 by 3 matrix. 2 rows, 3 columns. All right, so that's the order of a matrix. Very simple stuff. All right, and remember, you could only add and subtract matrices with the same order. Now let's put this on the Jamboard, and I'll write a note about adding and subtracting matrices. Okay, so that's on the Jamboard. Now back to here. Okay, that's one more before I write my notes. All right. A matrix with the same, all right, some switch back. All right, so the same number of rows as columns is called a square matrix. Okay, so example, if I had 2, -8, 5, 13, all right, we have 1, 2 rows, and then we have 1, 2 columns. So we have 2 rows and 2 columns. So this is a 2 by 2 matrix, right? I'll put which is a square matrix. All right, so a 2 by 2 matrix is a square matrix. All right, so example 1. Let's do our next one. That's more numbers. All right, example 2. If I have, using 8 all the time, all right, -15, 3, 21, 4, -1, 5, -8, -14, 0. All right. This matrix has 1, 2, 3 rows. All right. And 1, 2, 3 columns. All right. So this is a 3 by 3 matrix. Right. Same amount of rows as column. All right. I say, which is a square matrix. Okay. So let's give it a little note now. All right. So we know about the order of a matrix. We know its rows. We know its columns. All right. So now we're just going to say that on a matrix, we can only add and subtract matrices with the same order. Okay. Can only, put that only, capital, add and subtract matrices with the same order. Okay. Meaning, all right, let's see example here. If I add 8, 11 plus 4, 3, 9 like that, right? No solution. Don't have space to write no solution there. But let's type it out and make it small. All right, no solution. Okay, so no solution there. All right, if I had 4, negative 3, 8, negative 2, take away 11, 15. Again, the answer for this is no solution. Okay? Equal to, there's a simple arrow, and not a space there. All right, let's put an arrow like this. All right, no solution. Okay, and that's because these matrices have different order. This is a what? 1, 2, a 2 by 1 matrix. And this is a, write it. So this is a 2 by 1, put a different color. All right, this is a 2 by 1, 2 rows, 1 column, right? 2 rows, 1 column. And this is 1, 2, 3, 3 rows, 1 column. All right, 3 rows, 1 column, different orders, right? So you can't add them. All right, this is a square matrix. This is a 2 by 2, 2 rows, 2 columns. All right, so 2 by 2 matrix. And this one is 1 row and 2 columns. So it's a 1 by 2. All right, different orders. And you can see they look different, right? They look different. So you can't add them, you can't subtract them. No solution. All right. So some puts across the Jamboard. And then we get into how to, our time is, yeah, gonna be up. So I'll just do one example how to add matrices. All right. Next class we'll continue. All right, so let's put this across the Jamboard. All right, and what I think I'll do, I think Jamboard allows you a maximum of 20 pages. So same Jamboard, remember we have classes on Wednesday, Monday and Wednesday. All right, so I'll use the same Jamboard from Monday. So it'll be same Jamboard for the week, okay? So if you go on the Jamboard, you'll see everything that we did today. And then when Wednesday class come around, I'll just use the same Jamboard and just continue adding the pages. All right, so 1 Jamboard per week. All right, so now let's go across and give an example as to how to add matrices. An example or 2. All right, because I want to show one with all the directed numbers. That's to show you how to do it. And then I try directed numbers in it. All right. All right, so example. Let's say 2, 4 plus 8, 10. All right, as simple as that. It just means, shade, you know, this 2 will line up with this 8, and this 4 will line up with this 10. All right, so we're going to do 2 plus 8. Now you don't write out that. You can just say 2 plus 8 and right answer one time. All right, let's write in without teaching. All right, and 4 plus 10. All right, that's basically what we're working out. 6, simple addition, nothing big. All right, and as that's equal to 2 plus 8 is 10, and 4 plus 10 is 14. All right, and that's the answer. All right, so I say nothing big and complicated about this. All right, so you see 2 plus 8, so 2 plus 8, 4 plus 10, or plus 10. All right, let's give our next example. Tell subtraction. So if I take the same thing, 2, 4, and let's take that subtraction sign, 8, 10. Let's see what we get. So again, as you know, the 2 will line up with the 8, and the 4 will line up with the 10. So what you're going to have is 2 take away 8, and you're going to have 4 take away 10. And as you know, that directed numbers there because You're seeing the sign from the two numbers are different because positive 2 and negative 8. But the 8 is the bigger magnitude and the sign from the 8 is negative. So the answer taking the sign from the bigger magnitude. Signs are different, you have to subtract. So 2 from 8 is 6. But because the 8 is the bigger magnitude, the answer going to be negative 6. So that is sign from the 8. Answer taking the sign and the number the bigger magnitude. All right, so we're going to get negative 6. Down here we have 4 take away 10. Again, positive 4, negative 10. Signs are different, so you have to subtract. 10 is the bigger magnitude. Sign from 10 is negative, so the answer can be negative. Take away 4 from 10, you get 6. All right, so you're going to get negative 6. All right, so that's just a little sample. All right, next class we'll put up some bigger matrices and some with the brackets and stuff for the directed numbers and make it a little more complicated, and we practice our directed numbers like that. All right, so I put this page across on the Jamboard, and that will be it for this class. And remember, next class will be on Wednesday at 6 o'clock. Okay.